Hello, geometry students. Okay, so here we go. So today's our lesson is going to be on symmetry. Now, symmetry is, I would say, very important in the area of physics. I know when I studied, they always look for physics. Uh, but it's also in art. It's also in music. Uh, Symmetry plays a role. Symmetry, for some reason, people find very comforting or beautiful or interesting. It gives an order. Now, it's not saying things that can be chaotic without that lack symmetry aren't beautiful, but there is some relationship with symmetry and beauty. They actually say the most beautiful people in the world have the most symmetrical faces. I don't know if that's true. I'd have to check that out. But if you think about it, when we're looking at these things, symmetry means that if I cut something in half, the two sides are exactly the same. Okay, so we're looking for something that, when you cut it in half, you have two of the same pieces. They can't be different. Okay, so let's look at some of these examples I pulled up for us. I found this little worksheet on the internet, printed it up, and I said, okay, let's do this one because this one looks interesting. Okay, so the question is a line of symmetry. So a line is a line you can draw through any shape, and you have to see if this shape is a line of symmetry. Now, if you have it, sometimes what I like to do is I don't have a mirror on me. I don't have a mirror that's not on a wall, unfortunately, or that I could do with. But I used to like to hold a mirror up to something and then see if it still makes the same shape with the mirror or without the mirror. But the idea is that they're exactly the same shape on both sides of the line. Now, if you clearly see, with this one, the line of symmetry makes two half of a star. So this has a line of symmetry. So this is yes. This is no. They're congruent shapes. These two triangles are congruent, but they're not symmetrical. The same side is not on both sides. If you see one triangle is this way, and the other triangle is this way, for it to be symmetrical, it would have to look something more like that. This one is not the same on both sides. This one it points out on the top, and this one it points out on the bottom, so this is no. This one is symmetrical. Top and bottom are exactly the same. This is symmetrical. You see how this triangle here is just completely the opposite, same position as the other one. This one, very obviously no. This is a big triangle on this side, and he got a little bit, something that looks almost like a equilateral triangle here, so this is no. The heart. Yes. Here's an interesting thing with the heart. Let's ask ourselves this question. Well, it has a line of symmetry here, because these two sides are exactly the same. But if I drew a line here, well, that's not the same. Because here I have this one that's kind of shaped like an M on top, and I got this like triangular shaped one on the bottom, so they're not. But it does have a symmetry this way. So you can have symmetries in different ways, but not every way. Here we go. Here's a regular pentagon. Just to revisit some vocabulary from earlier in the year. So it's a regular five-sided shape. And if you go from this point here, yes. Because this shape is the same as that shape. Just opposite. So yes. Over here, no. Because you have one shape that kind of gets bigger at the bottom, like this, right? And this one on the other side gets smaller over here. So no. So as we're thinking about these things, let's think about if there's more than one way. So the first question they ask in this is, it says draw a rectangle that is not a square. Well, that's easy enough. I could do that. Even with my limited ability, I'll draw a rectangle that is not a square. Of course, my rectangle doesn't look very good. Damn. How am I going to do this? Let's make a better rectangle. I got a good one. Here is a good rectangle. That's a real rectangle right there. Look at that. That's a thing of beauty. Okay, so it says how many lines of symmetry does your rectangle have? Okay, well, let's think about this. Well, I'll look at the middle, because I'm going to cut this in half. The middle is the best place to start. Find the most middle part of this triangle, this rectangle. I say, well, if I cut a line of symmetry like this, there'll be two squares. There's a square on this side and a square on that side. They're exactly alike. Okay. But then I could do another one. Look at this one. Now this time, these two shapes might not be squares. This top shape here is a rectangle, and the bottom shape is an exact same rectangle. So I have 1, 2. Now, is there other ways to cut this? Imagine like cutting with a scissor. One way I'm going to mark in green that is not correct. Let's do it brown. No, let's do it in purple, because purple's not correct in my book. I can't do this. This is not a line of symmetry. Because this triangle here goes like this, and this triangle goes like this. Even though they're congruent, they're the same triangle, they're not opposite of each other. I'd have to flip this one like that. Now, the next thing they ask about here is the median of a triangle a line of symmetry for the triangle? So I remember that I understand that we don't remember what a median of a triangle is, so let's have a quick refresher course. First triangle I'm going to draw in this experiment is a equilateral triangle. I'll try to keep all the sides the same. So I'll make three-sided shape, close as possible to a close as possible. Pretty darn close. Okay, so I'm going to say, oh, I'm good. I'm going to say this is an equilateral triangle. I'm confident in saying it's an equilateral triangle. Okay, all the sides are the same. So, in an equilateral triangle, things are a little bit different. Okay, in an equilateral triangle, we have all the same angles, all the same sides. So, a median goes from the opposite angle to the halfway point on the following side. Well, you look at that, and you go, yeah, that's right. That looks like I cut that perfectly in half. Or I can go from here and go to the halfway point on the other side. Yeah, it looks like if you cut this in half, you'd have another one. Or I could go from here to the halfway point on another side. Wow, that looks like another one you can cut in half, have perfect symmetry. But that only will work in certain situations. Well, I'm not going to say only works for some triangles. Not all. And not all the way like this, not on all three sides. Because what I'm going to do next is I'm going to experiment. I'm going to make a crazy looking triangle. Okay, so let's not make a triangle that's so perfect like a right triangle or a equilateral triangle. I'm going to make something offbeat. I'm going to make a triangle that looks like this. Make it very long here. And I'm going to make it so this is my new triangle. It's a triangle. It's certainly a triangle. Forget this part here. But when I start drawing in these medians, look what happens. So halfway, let's look at the most extreme example, this big half, right? If I find a halfway mark, I'm guessing it's about here, and I draw it from here, from the other angle. No way. If you cut this in half, this side triangle on this side is completely different than this triangle over here. So that can't be true there. Now if I said, well, here's the halfway point of this one, and I drew it up to there, oh my god, these two triangles are completely different. They don't look anything alike. If you look at the one that goes from here to here to here, and the one that goes from here to here, not even close, not even the same size. So as you'll see, I've been drawing the last one, though. Hopefully I've made my point, that it doesn't work in all situations. Okay. Can a median be, I would say sometimes. It says, is the median of a triangle a line of symmetry? I would say sometimes. I think it works definitely for, I would definitely say it works for equilateral and isosceles in one case. You can do it in an isosceles triangle if you did it this way, right? So isosceles triangle might work like that, but those are the only times for equilateral and isosceles. Okay, guys.